All right. So this is for MAC 1105, College Algebra, Summer 2020. And I'm going to do sections 1-1, 1-2, and also 1-3. And so I'm just going to go ahead and work through these problems. These are similar to the ones that you're going to see on the homework assignments, the quizzes, and so on and so on. So for this one, since I'm multiplying both sides, I'm multiplying x by 7. If I divide both sides by 7, I get my answer, which is x is equal to 3 for this particular problem. When you have a fractional coefficient, what you want to do is you want to multiply by the reciprocal. And the reason is because then my left side, where my fraction is, where my variable is, I end up with x, right? Because 3 over 3 is just going to be 1. And then I can reduce this, right? So 3 goes into 15 5 times and into 12 4 times. So my answer is 5 fourths. For number 27, I have to do distributive property on both sides. So 2 times 3 is 6, and then 2 times 2x is 4x. And then it's going to be 3x minus 12. And then I'm going to just move the variable. I'm going to subtract the 3x. It just makes it a little bit easier to do. And then, of course, I'm going to subtract 6 from both sides. So x is equal to negative 18. For number 33, probably the easiest thing to do is to multiply everything by 4. The reason being is because 4 is divisible by 2, and of course 4 is divisible by 4. So when I do that, I'm going to multiply everything by 4. So if I do 1 over 2 times 4, which is really 4 over 1, I get 4 times 1 is 4, 2 times 1 is 2, so I get 4 over 2, which is equal to 2. So this becomes 2x minus 20, and since we saw that this is equal to 2, which was actually it's 2 times 1. In this case here, if I do 3 over 4 times 4 over 1, the 4's will cancel out, which is just going to give me 3. And so this becomes 3x. And then I'm going to subtract the 2x from both sides. So I get negative 20 is equal to x, and that's my final answer. Same thing for this one. Since 3 is my denominator, I'm going to multiply everything by 3. And as you can see in the previous problem, that's going to be 2x plus 1. That's going to be 48. And that's going to be 9x. Combine like terms, so 2x plus 49 is equal to 9x. I'm going to subtract the 2x from both sides. And then I divide both sides by 7, which is going to be x is equal to 7. This one's similar to the one that we just did, which the only denominator is x plus 3. So, of course, I'm just going to show you and then kind of go through it. If I multiply this by x plus 3 over 1, which is my reciprocal, these will cancel out. I'm left with 2x over 1, which is just 2x. So same thing here, that becomes negative 6. Now this one becomes negative 2 times x plus 3. So just kind of clean this up a little bit. So that's negative 2x minus 6. Combine like terms. Right? Then now what I'm going to do is I'm going to add the 2x to both sides. So I get 4x is equal to negative 12, which if I divide both sides by 4, I get x is equal to negative 3. Now for number 54, one of the things that you have to remember is that x squared minus 9 is actually the difference of squares. So if I multiply everything by x minus 9, you notice that the x plus 3 is going to cancel out, and I'm left with x minus 3. So if I multiply that by that, and that, here I get my x. Here I get my 4 times x minus 3, and on this side here I get my 3, because everything else cancels out. So this is going to 4x minus 12 is equal to 3. 5x minus 12 is equal to 3. 5x is equal to 15. I add both sides, and I get x is equal to 3. That's how you do number 54, right? Now, number 61, the denominator that I want, or the one that I can multiply everything by, is x minus 2x plus 5. So similar to the previous ones, if I multiply everything by x minus 2x plus 5, let me go ahead and get rid of this one here. My first one is going to be 4 times x plus 5. So let me show you why that's it. I'll just do this one here so you guys can see it. So x minus 2, x plus 5 over 1. X plus 2 cancel out, and I'm left with 4x plus 5 over 1, and that's how I get the 4 times x plus 5. So in this case here, I get the negative 3, x minus 2, the same concept. And here I just get 7 because everything is, and the denominator is just, they're just going to cancel out. Let me answer this. And so here I get 4x plus 20 is equal to negative 3x plus 6 plus 7. Negative 3x plus 13. Here I get my 4x plus 20. Add the 3x to both sides. You can do, you could have done either one. Subtract the 20. And of course, divide both sides by 7, and I get x is equal to negative 1. That's the end of 1.1. Now 1.2 here, we're going to factor these. So here I can factor out an x because they both have an x to give me. Then I set each of the factors equal to 0 with the 0 factor theorem, and I solve them. So my solution set for this one is 0, 9. These both values will give me a true statement, which would be 0 is equal to 0. So here again, when I do this, I'm assuming that either x is equal to 0, x minus 9 is equal to 0, they're both equal to 0. All right, for this one, for number 17, I believe that I had to use the complete the square. Let me just verify that real quick. For this one, number 17. Actually, no, it's also factoring. So for this one here, I got 2x squared, which is my first term, and then I have negative 3, which is my second term. I'm going to find factors of 2x squared, which is just 2x and x because it's a prime number. And then negative 3 is either negative 1 times 3 or 1 times negative 3. And I'm going to try different combinations of this in order for me to find what's going to give me the middle term, which is negative 5x. So I'm going to do plus 1, I'm going to do minus 3. Right? I could have chosen either one, I just chose that one. Now I'm going to do this in my head, right? So 2x times x is 2x squared. 2x times negative 3 is negative 6x. 1 times x is x, and then 1 times 1. And then you can see clearly here that that's going to give me my negative 5, which is what I want. Since I know that this is the factored form of the original, I'm going to use the 0 factor theorem. So this is x is equal to 3, and then this is 2x is equal to negative 1, and then I divide both sides. Oops. And I get negative 1 over 2. So my solution set is negative 1 over 2, and then 3. For number 31, I used the square root method, so I'm going to take the square root of both sides. So x squared is equal to 25. I'm going to do the square root of x squared is equal to plus or minus the square root of 25. So then x is equal to plus or minus 5. The reason is plus or minus 5 is because negative 5 times negative 5 is equal to 5 times 5, which is equal to 25. So my solution set is negative 5, 5. Same thing for number 33, right? Take the square root of both sides. So it's x minus 1 is equal to plus or minus 2. I'm going to add 1 to both sides. So I have two possibilities. X is equal to negative 2 plus 1, and x is equal to 2 plus 1. So this is negative 1, this is negative 3, and that's my solution set. Now for number 37, I have to complete the square. When you complete the square, ax squared plus bx plus c is equal to 0. What we're going to do is we're going to add the b over 2 squared to both sides. Now, the assumption here right now is that a is equal to 1. All right, so I'm going to go ahead and kind of get rid of it here. And so when I do that, I end up with x squared plus bx plus b over 2 squared is equal to c plus b over 2 squared. So I'll move the c over to the other side. And then what this gives me is x plus b over 2 squared is equal to c plus b over 2 squared. So that's what I want to do. And the reason being is because this here, I made it into a perfect square trinomial. So here in this case, b is equal to 4. So 4 over 2 squared is 4 divided by 2, which is 2. 2 to the second power is 4. So I'm going to add 4 to both sides. And then here, this is going to be 25. Now, x squared plus 4x plus 4. X squared is a perfect square. 4 is a perfect square. And then 4x is equal to 2 times the square root of x squared, which is x, times the square root of 4, which is 2. And then that's why we do this, because this is a perfect square trinomial. So then this becomes x plus 2 to the second power. Remember, I take the square root of the value that I added both sides. Then we take square root of both sides. This is plus or minus square root of 25. So x plus 2 is equal to 5, plus or minus 5. So plus or minus 5 minus 2. So x is equal to negative 5 minus 2, which is negative 7. And x is equal to 5 minus 2, which is 3. And my solution says negative 7, 3. For number 38, my b is going to be 6. 6 divided by 2 is 3. 3 to the second power is 9. So I'm going to add 9 to both sides. So x squared minus 6x plus 9 is equal to 13 plus 9. So 22 here. And again, that's a perfect square trinomial. So this becomes x minus 3 to the second power. Notice how it's a minus, because this is the sign that determines that. This one was a positive, because that's the sign that determines that. And then, of course, here I'm going to do what I've done previously, which is to take the square root of both sides. So x is going to, and sometimes the textbook writes it this way. So I'm going to go ahead and do it here so you guys can see it. So when I write it in my set, it becomes that. So number 40, again, the first thing I'm going to do is I'm going to move my 1/3 over to one side. Then I'm going to figure out, okay, what is 2 over 3 divided by 2? So that is going to be the same as 2 over 3 times 1/2, which is going to be equal to 1/3, right? Because the 2's cancel out. So then what I'm going to do is I'm going to square this, so it becomes 1 over 9. So I'm going to add 1 over 9 to both sides. Now, 1/3, I need it as a fraction with a 9 in the denominator, and I'm going to get 3, because 3 times 3 is 9, so 3 times 1 is 3, so I get 3 over 9 plus 1 over 9, which is 4 over 9. This one becomes x plus 1/3 to the second power. So x plus, hold on a second. All right. So I'm going to take the square root of both sides. And it's going to be x plus 1 over 3 plus or minus 2/3. So then this becomes x is equal to plus or minus 2/3 minus 1/3. So if it's going to be negative 2/3 minus 1/3 is negative 3 over 3. Negative 3 over 3 is negative 1. And then if I have to do the plus 2/3 minus 1/3 is 1/3. So my solution set is that. For number 44, I'm going to use the quadratic formula, which is x is equal to negative b plus or minus 4a, not 4a, sorry, b squared minus 4ac over 2. So here a is 1. b is 4, and c is 2. So x is equal to negative 4 plus or minus 4 squared times negative 4 times 1 times 2 over 2 times 1. So negative 4 plus or minus 16 minus 8 over 2. Combine the like terms here. Now negative 8, square root of 8 is equal to 2 square roots of 2. The reason being is that the square root of negative 8 is equal to the square root of 4 times square root of 2, right? Which is 2 square roots of 2. You'll see that a lot. I'm going to combine here, kind of cancel stuff out. Oops, no. 2 square roots. So my answer would be negative 2 minus the square root of 2, and negative 2 plus the square root of 2. In this case, we're going to find a discriminant. The discriminant is just the value of b squared minus 4ac. If this happens to be, and I'm going to have it here, if it happens to be positive, then you have two real solutions. If it's equal to 0, you have a repeated solution, which is just like x minus 2 to the second power. If it's negative, then you have no real solutions. In other words, you have complex solutions. And so for here, I'm just going to find a value. So it's going to be 5 squared minus 4 times 3 times 8 times negative 8. So this is 25 minus 96, and you can clearly see that that's going to be negative, so this has no real solution. All right, let's go over to 1.3. So I kind of already went over discriminants, so I won't do that again, but just remember here, I squared is equal to negative 1, and the square root of negative 1 is equal to I. This is a nice little pattern that helps us to solve problems. If we come across with I raised to different exponents, we can actually simplify those a bit. But the first thing is just be aware that complex numbers are in the form of a plus or minus bi. That's the way I always want to write it. This is the real term, and this is the imaginary term. So the way that we do this is we do component-wise. So 2 plus 6 is going to be 8. Negative 3i plus 8i is going to be 5i, so my answer there is 8 plus 5i. Here, I'm going to do negative 3 minus 4, which is negative 7. And then I'm going to do 2i minus negative 4, which is the same thing as 2i plus 4i, which is going to be 6i. Now for number 17, I just do distributive property, so that's going to be 6 minus 18i. For number 19, if I, again, do distributive property, I get 4i minus 6i squared. Now, we said that I squared is equal to negative 1. So then this becomes 4i minus negative 6 times negative 1, which is 4i plus 6, which is when we're going to rewrite it in a plus bi form. So it's 6 plus 4i. Now here, when we have a fraction, we want to multiply by the conjugate. So the conjugate of the denominator is 3 plus 4i. So I'm going to multiply the top by 3 plus 4i and the denominator by 3 plus 4i. So this becomes 10 times 3 plus 4i. And I'm going to show you what happens. Why do we multiply it by the conjugate? The reason we do it is because we end up with a real number. So 3 times 3 is 9. 3 times negative 4i is negative 12i. 4i times 3 is positive 12i, and then 4i times negative 4i is negative 16i squared. The middle terms cancel out. We know that I squared is equal to negative 1. And this becomes 9 plus 16, which is 25. So my denominator is 25. Now I'm going to clean this up a little bit. So this is going to be 30 plus 40i over 25. And then what I have to do is I have to write it in my a plus bi. So this becomes 6 over 5 plus 8 over 5i. That's the answer for number 25. Now, number 23, what we can do here is we can write it as I to the second power times I to the first power. Now, I to the 22nd power is the same thing as I squared raised to the 11 times I, right? And so because 2 times 11 is 22, I can do that. So I squared, we said, was negative 1. Negative 1 to the 11th power, since it's odd, is going to stay as negative 1. So then this is just going to be negative I. Now, for this one here, I'm going to write it as a positive exponent. Now, I can do the same thing, right? I'm going to go ahead and do I to the 14th times I to the first. Now, I to the 14th, I'm going to rewrite as I to the second power raised to the 7th power times I. And then this is going to be negative 1 to the 7th power. And so times I. So that's going to be 1 over negative I. And so what happens here is going to multiply the top and bottom by the conjugate. So I can get rid of that. And so here I have I, and a negative I times I is negative I squared, which is I over negative, it's actually I squared is negative 1, so a negative and a negative is a positive. So then this just being, it becomes just I. For 49, the square root of negative 4 is the same thing as negative 1 and 4, which is I, and 2, which is 2I. For number 55, we're going to subtract the 4 from both sides. I'm going to take the square root just like we did previously. Now we know that the square root of negative 4 is 2I, but this becomes plus or minus 2I, so my solution says negative 2I and positive 2I. Now, number 59, we're just going to go ahead and use the quadratic formula. So it's going to be 6 plus or minus negative 6 squared minus 4 times 1 times 13 all over 2 times 1. So what we're doing here now, we have the following, right? We have to kind of clean this up a little bit. So then this becomes 6 plus or minus 36, and then minus 52 over 2. So 36 minus 52 is going to give me negative 16. So it's going to be the square root of negative 16 over 2. Now in this case here, negative 16, I can break that up into 4 times 4, right? Now both of those are perfect squares. Now 16 is a perfect square, sorry. So then the square root of negative 16 is just going to be negative 4. So it's going to be plus or minus, sorry. It's actually going to be plus or minus 4I, right? And then I can kind of clean this up a little bit, which is going to be 3 plus or minus 2I. So your solution set is going to be 3 minus 2I, and then 3 plus 2I. All right. For 69 and 70, these are the last two. So if I have a to the third power minus b to the third power, I can break that up into a minus b, right, times a squared plus ab plus b squared. Now, if it's a to the third plus b to the third, they're both perfect cubes, then I get a plus b, then a squared minus ab plus b squared. So as long as I identify what a and b is, I'm okay. I can use these formulas. So then this one becomes x minus 2 times x squared plus 2x plus 4, right? And so now that I have these, I'm going to try to see, because they're equal to 0. So I'm going to just try to see if I can factor this a little bit more, if I can kind of clean it up a little bit. And so I just have to see what parts of these I can factor. Sometimes you can't factor the quadratic part of it, and so you just have to kind of leave it alone, right? So here, we're going to have the following, right? So x minus 2 is equal to 0. It just means that x is equal to 2. Now, x squared plus 2x plus 4 is equal to 0. I'm going to use the quadratic formula. I'm going to keep this space here so I can keep it. So x is equal to negative 2 plus or minus 2 squared minus 4 times 1 times 4 over 2 times 1. So then this becomes 4 minus 16 over 2, right? And so it becomes negative 2 plus or minus square root of negative 12 over 2. And so then what happens is that the negative 12, I can break it up into, basically becomes 2 times, so it becomes 2i times the square root of 3 over 2. And of course, when I even clean up more, it's going to be negative 1 plus or minus I square roots of 3. Now, there's several ways that you can write this. You can say, okay, so it's going to be negative 1 minus square root of 3i, and then negative 1 plus square root of 3i. For number 70 here, again, we're going to identify. So this becomes x to the third plus 3 to the third is equal to 0. So it's going to be x plus 3, and then x squared minus 3x plus 9. So of course the first one, x is equal to 3, to negative 3, right? That's the first solution that I have, which is my negative 3. Now, for the next one here, I'm going to use the quadratic formula, right? And so I'm going to kind of plug in some values. So it becomes 3 plus or minus 3 squared minus 4 times 1 times 9 all over 2 times 1. So 3 plus or minus 9 minus 36, which is going to be negative 27. Right? Oops. Over 2 over 2. And so when I do that, what I end up with is the following. I'm going to end up with 3 over 2 plus or minus 3 square roots of 3i over 2. So when I write it, I got my negative 3. Then I got my 3 over 2 minus my 3 square roots of 3 over 2i. And then I got negative 3, no, not negative 3, my 3 over 2 plus 3 square roots of 3i over 2. And that is 1, 1, 1, 2, and 1, 3. Thank you.